Hello everyone, welcome back. And today I'm going to talk about the main of the talk problem. Okay, when we solve the talk problem, this is one of the best problem in the rotational motion. Okay, so here's examples, exercise 5. I already talked about the exercise 7 and 4. And here's about the talk. You can, before we start, you can write it down in your paper, or you can take a picture, a screenshot, whatever you want. This is a question. This is a very good question. I'm assume like 90% in the exam. This problem might be in your exam is about like 90%. I'm pretty sure, because this is one of the most professor like this problem, because that way they can test you the how you learn about the net, how you find the net thoughts, and then how you use the right hand rule. Okay, but in this session I'm going to talk about everything about what you need to know. Okay, most of the professor and most of the most of people like to learn, they use the right hand rule. Okay, right hand rule is very simple. Okay, they use like this. So right hand we have to use only right hand. We can use left hand when you was solving the problem. Okay, but for me, when I trying to do the right hand rules, when I'm trying to do like this, my hand is very stiff, so I cannot do that. So I'm going to teach you, and I'm going to show you the best easier way. You don't need to be hold like this in the exam. Okay, you don't need to do like that. You just only need to memorize and keep it in your mind. Okay, so before we start, I always say about the tips and trick. So this problem about the tip and trick is this one. This is my cheat sheet. This one. This is mean counterchloride. Is always counterchloride is negative into the page. Chlorwise is, I'm sorry. Chlorwise is negative, is always into the page. This is the sign is cross, is a chlorwise, and the counterchlorwise is positive, is out of the page. I'm going to show you the example. Okay, so this is the clock. Okay, so it is 12, 3, 6, 9. Okay, so if the clock is, as we know, if you don't know, just look at your clock. The clock is going like this. Okay, it's moving like this. So this is mean clockwise. We say clockwise. So if it's this one is moving like this, when you see this is the clockwise, then that sign is negative, which mean into the page. Into page, we say the sign is cross. Okay, it's very easy, and you have to keep it in your mind this, or you can write it down in your cheat sheet or in the note paper, if you want. Okay, so if the clock is going, usually the clock is going like this, right? If the clock is, when you see the clock is going like this, just like a reverse. Okay, this is the reverse. We say counterclockwise. Okay, is plus, is out page. See why the sign is dot. Okay, so now I'm going to show a very easy way. So if it's go like this, it is close white, and if it's go like this, it is counter close white. It's always positive, the sign is out of the page. It's always negative, the sign is into the page. That's what you need to know about this problem. If you know about this problem, it's gonna be very easy. This is the main point. Okay, so all you need to do is just this, and other thing is just plug in the numbers. Okay, if you want, you can take a picture or screenshot for this one. That way it's more easy for you. Okay, so I'm going to go this way. Okay, so let's read the question. Okay, let's say example 5. So the question is asks a 20 centimeter diameter disc in the figure can rotate on an axis through its center. So this is a 20 centimeter. So this, the whole thing is, this radius is 20 centimeter. So this R, okay, this whole R is 20, and it's rotate on the axis through the center. Okay, they are rotating through the center. So the question is, what is the net torque about the axis? It's very easy. They asking to find torque, net torque. Is tau net. Net torque is mean tau net. Okay, you have to keep it in your mind. So tau net is, before we start, I know also there's the question give a figure, a picture. Okay, so a picture we going to give it. I give it like this is 1, this is 2, this is 3, this is 4. Okay, so I give it like this. Okay, so let's we see this one. Okay, we're gonna find this one. Don't look at this side, don't look at this side, only this part. Okay, we only look at this part. So before we start, we're going to write equation. Okay, we're going to write equation. The equation is, I already told before, tau t is RF sine theta. This is the equation. Okay, I already say here, what is this? Oh, tau is here, RF sine theta. Okay, so we're going to find t for 1. Okay, so I will say t1, tau 1 is RF sine theta. RF sine theta. Okay, so what is the R? R is radius. So we see from here, where is the radius? The radius for this side is we always look at starting from the force. This is the force, okay? As we know, the Newton is the force. Daddy is the force. If you see the force of the tail, we look at starting from the tail here. This tail here is going down. This is the radius. So when you see the radius from here is starting from here, this whole radius is 20. So this is the only half breadth. So we say half breadth is 10 centimeter. So half is 10 centimeter. We don't want the centimeter. We want like meter. Okay, every time we solve the problem, we want the meter in physics. So that's why we're going to change. So that's going to be to change the centimeter to meter. We're going to divide them with hundreds. So 100 is 10 into 10 power minus 2. So minus 2, 1, 2, so 0.10. We get 0.10. Okay. So we write R is 0.10 into, what is F? F is easy. 1 is F1. So it's daddy. Okay, we just plug in the number, daddy. Okay, and also sine. What is theta? Theta is, you will see, oh, the angle is 45, but this is not round. This is for the picture too. Okay, we're going to see this size. As I told you before, we're going to see with at the end of the tail of the force. The tail of the force is here to here, so it's perpendicular. Okay, if you see the right hand rule, the picture is like this. This is the force, so it's going to be like this. Okay, so the force is like this. It's going down, so it's gonna be, this is the angle. This is the angle. Okay, you can see this is the angle. So this angle is 90, right? Because if you see draw like this is the angle of the triangle. That's why the angle of the triangle is 90. Oops, sorry. Angle of the triangle is 90, so that's why we write sine 90. Okay, when you solve this, you will get meter Newton. I think is this. Let me use. I'm trying to find this. 0.10 into 30 into sine 90 equal to 3. Okay. So the answer is 3, but it's not finished yet. If you finish the answer for T1 is here. If the professor give you 2 points, you will get only 1 point because you forget the sign. You not completely fill up the sign. So we need to fill up the sign for every talk to find every top problem. Okay, top problem. So here is, we're going to look up the picture again. We always see, if you know about the right hand rule, this is my left hand, this is my right hand. If you know about the right hand rule by seeing the picture, you will see this is going inside or outside of the board. Okay, then you can give a sign, positive or negative, whatever you want. But for me, I'm going to show you the easier way, my way. Okay, my way is, I just look at it like this, always trying to see with the force here. The force is going to rotate here. Okay, the force is not going to rotate this side. It's very obviously it's going to re-rotate like this. Okay, because it is the angle, so it's going to rotate like this. So that's why it's going with, we can see here, if it's going like this, it's going to be clockwise. The sign is negative. This is out of the page, sorry, into the page. Okay, so that's why we write negative 3 Newton, and the sign is cross. Okay, it's very easy. Okay, we can forget this one and this side. If we forget it, you can find that your answer of the tau net is going to be wrong. Okay, and also we find tau 2. Tau 2 is same thing, r of sine theta. So tau 2 is here. So what do we see in the tau 2? Always, what I said is always to get the tail of the first, always to get the tail of the force. Tail of the force here. Okay, this force to here, you will see the radius because it's starting from here. Okay, that's why this is only the radius is, as the picture is show, 5 centimeter. So we're going to change centimeter to meter, is convert 0.5 centimeter for the radius. So this is 0.5. Force is 30. It's 30, and sine, this time the sine is 45 because this picture is given. Okay, so we're going to solve this. 0.5, 30 sine 45 is going to be 0.0. If I change the 5 into 100, 5 divided by 100 is 0.05. Sorry, 0.05. So 0.05 into 30 into sine 45, which is equal to 1.06. So we write it 1. Okay, so 1 meter Newton. Okay, we're going to see the sign, the same thing here. What I said is always rotate inside the center, so it's going to be rotate like this. Okay, so this is what I said is, if the rotate like this way, is going to be counterclockwise. If it's counterclockwise, the sign is positive, and then it is out of the page. Out of the page is dot, into the page cross. Okay, I hope you can understand this. And also we're going to find T3 is r of sine theta. This time for the T3 is r is radius. Okay, radius is for this one is the same thing, 0.05, because it's the given, and force is 20. Force is here 20. So this one is 20 sine. Okay, we're going to look at the theta. We look at the theta, just the angle is not given, so when we look at the tail, it's going this way, right? So it's perpendicular, so it's gonna be this angle, so it's 90. If the angle is perpendicular, it's gonna be 90. 0.05 into 20 sine 90 is 1. Mm, 1 million Newton. That is also, this one is rotated like this, so it's gonna be counterclockwise. Counterclockwise, the sign is positive, and there's this. Okay. I think this should be something wrong. 30 into sine 45. I think I forgot to write C106. Okay, because we have to write exactly. And we find T4. Tau 4 is very easy. Okay, you have to know that in your mind, keep it in your mind. If the 4 is passing through the center, that's gonna be the tau. There's no tau net. There's no tau if the 4 is passing through the center. Okay, there's no tau. So that would be the answer is 0. Okay, because you can see it's passing through the parallel. See, it's passing through the center. The forces for the 4 is passed through the center. That's why I'm right for the T4 is 0. You can see in here there's no passing through, there's no passing through the center, but for this one is the force in the outside that also is passing through the center. That's why we write 0. Okay, now we find the question is asking the net torques. Very easy. T nets. Tau nets is we just combine everything. Okay, so minus 3 plus 1.06 plus 1, which is equal to, I'm gonna use my calculator. Minus 3 is gonna be the negative, the sign negative, because 0 minus 0.94 meter Newton. If the sign negative is gonna be counterclockwise, so this will be close. Okay, it's very easy and is a good problem to solve to test you about the net torque. The net torque is very important. I think even you're gonna be learning about net torque stay in the, I think 121 and 141. I believe because that's a very important lesson. If you don't know about the net torque, the physics will be the nightmare forever for you. So learn about what I said. If you have any question or anything, if you don't understand what I said, I just suggest reverse the video again and then look at the video very carefully, because I explain you everything about very easy way. Okay, there's no trick, nothing hide it. I just give everything what I know. I just sharing, because sharing is caring. So if you have any other extra question or any about this question, ask ChatGPT or any kind of AI, or you can ask your professor. Don't ask to me, because as I already told, I'm not a professor, I'm not a tutor, I'm just like you, a student. So yeah, so alright, I think I'll see you in the next video. Okay, so alright, thank you for watching.